The main responsibility of a dockmaster is to manage dry docking operations safely. A dockmaster is not expected to design the dry dock, but must ensure that the vessel, blocks, dock structure, pumping system, stability, and operational sequence remain within safe limits. Every docking operation must be planned, calculated, checked, controlled, and documented. Most accidents occur when assumptions are made about vessel weight, block loads, water levels, clearances, or stability. There are different types of dry docks. A graving dock is a fixed structure built into the ground and separated from the sea by a dock gate. It is long-lasting, suitable for large vessels, and does not require floating dock stability calculations. However, it has a high construction cost, cannot be relocated, and is difficult to enlarge. In this type of dock, floor loading, sidewalls, drainage systems, dock gates, and groundwater pressure must always be controlled. Floating dry docks lift vessels out of the water by buoyancy. The pontoons provide lifting force, while the wing walls provide stability and longitudinal strength. These docks are mobile, flexible, and economical for many shipyards. However, pumps, valves, tanks, and steel structures require regular maintenance. If ballast compartments are not emptied correctly, reverse bending, overstress, or loss of stability may occur. A marine railway is a system that hauls a vessel from the water to the shore along an inclined track. It consists of a cradle, track, foundation, hauling chain, and hauling machine. It is low cost and fast, but the rails, chains, rollers, and underwater components must be inspected regularly. Track slope, hauling power, vessel trim, and cradle stability are very important for safe operation. Vertical lift systems place the vessel on a submerged platform and raise it vertically with synchronized hoists. This system is fast and provides good transfer capability. A marine travel lift, on the other hand, is commonly used for smaller craft and lifts the vessel with slings before moving it to a repair area. In both systems, load distribution, sling angles, platform strength, and vessel stability must be carefully checked. The docking plan is the main document for the operation. The dockmaster must always use the latest approved version. The plan includes the vessel profile, plan view, keel profile, block positions, side block offsets, underwater openings, propeller and rudder clearances, draft marks, and block pressures. If no docking plan is available, previous docking reports, sister vessel information, shipyard records, and diver inspections should be used. All estimates must be conservative. The dockmaster must confirm whether the vessel physically fits the dry dock. Beam, length, draft, keel bearing length, water over blocks, side clearance, and vertical clearance must be checked. Sufficient clearance must also be provided for appendages such as propellers, rudders, fin stabilizers, sonar domes, skegs, bilge keels, and sea chests. Incorrect clearance calculations may damage the hull, blocks, or dock structure. A vessel afloat is continuously supported by water pressure. In dry dock, this support changes into concentrated loads on the keel blocks and side blocks. Therefore, blocks must be placed correctly under the vessel's structural members. Keel blocks carry the main load along the center line. Side blocks prevent overturning and must contact suitable structural points. Incorrect block placement can cause hull deformation or local overload. Blocks behave like large springs. Higher blocks take more load, while lower blocks take less load. For this reason, block height, material stiffness, and bearing area must be correct. Blocks with different stiffness should not be mixed in the same keel line. Softwood caps absorb small irregularities. In the case of narrow keels, skegs, or bar keels, high pressure may occur, and hardwood spreaders or steel plates may be required to distribute the load. Block loads must be controlled by calculation, not by guesswork. The trapezoidal loading method estimates the load per foot by using vessel weight, keel bearing length, and LCG eccentricity. However, further analysis is required if the vessel is damaged, block spacing is irregular, some blocks are omitted, keel width changes, or the vessel has excessive overhang. Interrupted keel bearing can create dangerous load increases on the remaining blocks. Stability is one of the most critical subjects in dry docking operations. Even if a vessel arrives stable, its GM may decrease as it lands on the blocks and buoyant support is gradually removed. The knuckle reaction at keel touchdown virtually raises the vessel's kg and reduces stability. The vessel must remain stable while the side blocks are hauled into position. Before undocking, all weight changes must be tracked and the new GM must be calculated. Every weight added, removed, or shifted during the dry dock period must be recorded. Repairs, equipment removal, new installations, tank levels, and free surface effects can change the vessel's final float-off condition. Before undocking, the new displacement, drafts, trim, list, LCG, TCG, KG, and GM must be calculated. The vessel should only be undocked after it has been confirmed that it will float safely. Block construction and block inspection are essential for safe dry docking. Timber, concrete, steel, sliding, hydraulic, or adjustable blocks may be used. Timber must be of structural quality and checked for rot, crushing, and cracks. High blocks require cribbing or bracing. The force on a side block must pass through the middle third of the block. Otherwise, the block may tip over. All block heights and offsets must remain within tolerance. The docking procedure consists of advanced preparation, facility preparation, pre-docking checks, the docking operation, and post-docking checks. The latest docking plan, tank soundings, drafts, trim, list, weather, tugs, pilots, lines, divers, communication, and pumping plan must be confirmed in advance. During the operation, the vessel must be centered correctly and land on the blocks at the expected water level. If unexpected early contact occurs, the operation must be stopped and the cause must be investigated. For safe dry docking, the dockmaster must always control 5 key elements: vessel condition, block loading, stability, dock structural limits, and operational sequence. The pumping plan must match the vessel's actual load distribution. Dock certificates and capacity limits must be known. Regular inspections must be carried out, and all changes must be recorded. A successful operation is based not on assumptions, but on planning, calculation, control, and disciplined execution.